In today's episode, I'm going to break down and teach you guys why and how we can use a stack in programming to structure our data. This is the first episode of my data structure series in Python. That's right, last in, first out. Today's episode is all about stacks. Let's dive in. Welcome back, guys, to another episode of Code with Josh. For pretty obvious reasons, I'm Josh, and I'm stoked to have you guys here. You guys have been asking me for a long time, Josh, data structures, algorithms, put out some videos on DSA, right? Well, I'm here to tell you this is that. Do me a favor, guys. You've been waiting. Smash the like button, click the like and subscribe, as that does help me, a growing small channel, reach more students around the world. And this is only going to be the first video on an ongoing series of data structures and programming that I'm going to put together for you guys, breaking down these advanced structures outside of the realm of only Python. Because in Python, you've learned the four built-in: lists, tuples, dictionaries, and sets. It's now time to take you up to the next level. And over the next mini series that I'm putting together for you guys, I'm going to cover these 6 data structures in programming. And here's my guide, actually, that I handmade for you guys. And it's going to be in the link in the description. Okay, the link in the description is going to be my free Python newsletter that allows me just to teach you guys more, right? But I'm going to include my Python and Git starter pack, as well as this data structures and programming guide. Absolutely free. It's down there in case you missed it with my 3 free Python courses, either for beginners or if you want to get into app development. Over 30 hours of courses, absolutely free. So use the links in the description, guys. Everything I have is pretty much free. That really does help support me. If you want to subscribe to my premium content, that's on my newsletter. Just launched, new to you guys. All right, enough chit chat. Today's all about stacks. Let's break down what are stacks. Stacks, the first data structure in our series. I hope you guys like the illustrations. So really how I want you guys to view it right now is a stack is like a list. You know how to work with lists? Go with it. Okay, we'll build on that. So this stack follows a last in, first out format, LIFO. Last in, first out. Drill that into our heads, okay? And here are a few popular reasons that we commonly use stacks in programming. Now, I'm not going to cover these all. These are just my examples, right? We could have a function call stack. We undo operations. I use this, right, on the keyboard. Control Z. You do something, you want to undo it, right? It's like a stack. We just remove the last thing we did. We have expression evaluation, syntax parsing, and today the example I put together for you guys is going to showcase memory management. All right, now the key takeaway, right? So stacks are like a list and they follow the last in, first out format. This format is literally like a stack of plates because dirty dishes, we put the dirty ones in a stack, and as we clean them, we take them off the top. Okay, I'm not going to take the bottom dirty plate. Why would I do that, right? We take the top off, we clean it, then the next one. That's how a stack works, right? A visual I made for us is right here. If I have an empty cup, I'm going to add, or I'm going to push one item to it. Every time we add, we push. But then when I remove, I pop the latest element off the top. Here's a visual breakdown if we view it as a list, right? So I take my stack, we essentially append a number, a new element to the end of it, right? That generates this list, an updated version, and it really acts as like we're appending. But it also acts as a stack of plates because now when I decide to remove elements, I'm not choosing an independent element. I'm not removing the first element. That's a different data structure. I'm removing the latest one that we put in, right? So if I have 88, 78, 23, I'm now left with this remaining stack of dishes, 3 dishes. What we're doing here is I'm popping an element off, right? Pop, have you heard of that in Python? Have you used it? The pop function. In order to create a stack in Python, we really want to create a class to manage this. And the stack class is going to manage the methods that we associate with a stack. So we need to address what's different with a stack than a list. What can a stack do differently, and how are we going to implement that? Well, action 1, we can add items to a stack. Action 2, we can look at the stack. I can peek. So when I peek at the stack, I don't want to alter its original state. I just want to view it without changing it. We can remove items from a stack, pop, and then we can check the size of a stack, right? How big is it? And then we're going to check if it's empty or not as well. Okay, just remember to test our stack frequently, and the key takeaway is our stack is a last in, first out data structure. So knowing what you already know with lists, how could you create a class for adding and removing to lists? But we're going to tweak that for stacks. It might seem a bit redundant, but it's not, because they each serve a specific purpose. Now that we know what we need to create our stack with, let's jump into VS Code and code out a stack. So here you see I have structured out everything we just looked at, all those tasks that we needed to do. I broke it down for us, so now we can go by step and create this program, this data structure that we need. So I'm going to go step by step here. Let's create our class, and I'm going to create a class. For this sake, let's just call it a stack. Right now, I am going to initialize this. Why am I going to initialize this? Well, I need to create my stack. And what is our stack? I said it's like a list. So right now, I'm going to create a list. We will optimize this later to make it more efficient. But this list, it sort of functions the same way. Let's make it. So now that we have this list, we can do stuff with it. What is an action we can do? Well, an action we can do that we looked at is we can push. Right? I can add an element to my stack, and because the stack is a list, I can really just append. Right? Now, what do I want to append? Well, we need to append an item, so I'm going to give that as the other parameter. I'm going to start to run some tests, right? So we can see that we push the stack, right? Let's just test to make sure everything's working as we go through the creation of this data structure. So at the bottom here, let's just say if the name is our main file. Okay, I'm going to create an object. Now, today I did tell you guys that I was creating a memory management system. So let's imagine that we're working with APIs. So like Flask, for example. Flask works with APIs that we can route to different pages. Let's think of it like that. So I'm creating a stack to manage my URLs. All right. Now that I have a stack object, we can push things to it. So as a test, I will take my stack, push, I'm going to drop in a URL. Let's imagine we're working with this template page, right? So example.com. Okay, I'm going to do this a few times. So you can see that my main URL is the example page, but because we're working with APIs, Flask, in our example, memory management, browser management, okay, these are all other paths to different sites, to different pages, on our website. Okay, so I want to be able to manage, because as I click through pages, right, if I click the back button, I want to go back. I want to remove the last element, last in, first out, and I want to go back to the previous page. So we're pushing this. As a quick test, I'm just going to come down here and I'm going to print off, let's say like current stack, tap into URL stack, and then just tap into your stack list. Run your code. You can see here our current stack in a list format. We're good to go. This is wonderful. Okay, so test 1 complete. Let's move on. What is the next part of a stack? Well, I want to be able to remove the last element of the stack. Not the first, not the second, the last, because that's how a stack works. The next thing we can do is delete an item from the stack, right? So if I were to get started here, I could call this pop. Right, it's going to take self. Now, what errors could I face? Well, I could face an error where I have an empty stack, and I want to address this first. Okay, so I'm going to make a method to check for empty real quick that I can use outside of my class for a looping purpose. So right here in pop, I'm going to say pass. Okay, because let me first check if our stack is empty. So let's just create a method called isEmpty. Okay, the only thing this is really going to redo is it's going to return the length of our stack, and it's going to say equals 0, right? So if it's true, our stack is empty. So now that we have this to check for an empty stack, I'm going to say right here inside pop, if not, right? So I need to make sure that our stack is not empty. So if that is not true, I would like to remove the last element of a stack, right? That's how it works. So I'm just going to return, take my stack, and call pop. I'm going to create an else because what could happen? I would like to raise an index error if that occurs, and I'm just going to say pop from an empty stack, right? So I tried to pop from an empty stack. I know the error that's going to happen. Okay, so pop looks to be good. Okay, I'm going to come down here to do some testing. Okay, let's clean that space. Let's say what is the current page? This should be the last page in my stack. So let's take URL stack, let's say pop. Okay, I'm gonna come down here and print off, let's say current page, and then let's run our current page. Let's run the code. Voila, you can see the current page in my stack. We know that test is working. Let me remove all the pushed items and let's try and run it on an empty list. Stack. So I'm just actually going to turn these off. Let's just rerun it. Boom. You can see I'm thrown the error and you can see it's giving me the index error that we specified, right? So your tests are working. Everything is going good for your stack implementation. Now, what is next? I want to peek. How can I look at my stack without changing its state? Because I just want to view it. Let's close up our terminal. I can turn this code back on. Okay, we're good. Going up now, we want to add the peek functionality. So I'm going to say peek, right? Inside peek, I'm going to also make sure that we are not empty, right? So if it is not empty, I'm going to return the stack, but I want to index the last element. Okay, so I'm just giving it back. We're not really doing much with that. Else, once again, let's raise an index error. And this time we're just going to say peek from an empty stack. Okay, let's do our quick check again. So I'm going to sneak in here before I pop it. And all I can do is let's tweak this. Let's say current page, right? So let's peek at the stack. So I'm going to say url.peek. I can peek at the latest page. Now the current page now is going to change, right? Because I'm popping. So if I pop, maybe I navigate back to a different page. Okay, so when I run my code, I'm going to peek at the last item, and then I'm going to pop it. So I'm going to navigate back to our previous page. Boom, there you go. You can see my current page, and then here we actually popped it off. So I guess I didn't run that. Let's do this now. Let's just say URL stack. When I run this now is a better one. So we've actually removed that URL from the stack, the subpage right here. Okay, so everything's working very well. The last functionality is just the size of my stack, right? How many URLs are we working with here? I like to add this one because then it allows you to keep track of what you're doing. Okay, so if we go up, let me trash this, okay? Check the size. We should know how to do this, right? Size, what do you think we're gonna do here? Well, let me get my grammar right. Return the length of your stack. How am I going to use this size now? Well, imagine we want to do some things. So I want to just repeat a certain task. And I could say while my URL stack is not empty. So we're going to say empty here. Okay, this is going to act as a loop, which will allow us to stop later. So I can continuously remove items. For example, we get on a website and I start clicking links on the website to take me to other pages within. I can click the back button so many times until I get to my starting position, and then it stops. Okay, so the same actions apply. So while our URL stack is not empty, let's just pop off individual elements. So I can say URL stack, let's just pop, and it's going to loop. To make this a bit more readable, let's drop in here, and let's just see how big the size was. Okay, so when we run our code, you can see that we've gone through, and then remaining URLs in the stack after our pop are going to be these three. And it stops, right, once our loop breaks. So once the stack becomes empty. Until then, we continuously remove the last element in our list, our stack, right, until it meets that threshold. Now, this is pretty much done, right? I've introduced to you guys stacks, but I want to optimize this further. Let's go to the top of our code, actually. I'm going to close the terminal. One of the ways that I could further optimize this and make it more efficient just in Python and the way everything is structured is creating a queue, well, a deck. But a deck is used for a queue. But let me just import that. So I'm going to say from collections, I would like to import deck. So we are going to look at deck, and this is commonly used to create queues, which is going to be another data structure in my data structure series. So don't worry, but for now, let's run our code and just know that deck works the same way as a list, right? Allowing us to append and remove items in the way that we see fit. And a stack is LIFO, last in, first out. Run your code. This is the only real difference you see deck, which is being printed off and returned here in our current stack, is just returned as a deck, which internally is a list. But everything else in your stack works the same. That's wonderful. You now know how to create your own stack, so hopefully we can implement this into your projects. Well, if you guys got value in today's video, do me a favor and like and subscribe. That really does help me in the YouTube algorithm, and it helps me reach more students. I know you guys have been wanting this broken down. That's why I put together today's video. Sorry, right? And I will be going through the rest of these data structures for you guys. It won't be back to back because I want to include some other projects coming out really soon, right? Ways that we can implement this. So now that you know a new data structure, stacks, I want you to head on over into a project and think about how could you use this and try and create your own stack and implement it there. Guys, remember, you can get this data structure guide I made, as well as my free Python and Git starter pack. They're the links in the description that you'll get by subscribing to my free Python weekly newsletter. Absolutely free, okay? If you want to support the channel, all right, there is a premium newsletter and content down there, but just use the guides I made, okay? That's why I made them for you, all right? Then you can get those with my courses I have down there. Free 30 hours of Python content coming at you live, right? Taking you from beginner to knowing, or explore app development with me. Well, guys, that's enough for today's episode of Data Structures in Programming. And in this episode, you learned stacks. And I was stoked to bring that to you. Thanks for tuning in for another episode of Code with Josh. Until next week, Python crew, I'll see you then.